Hello students, welcome to section 14. We'll be doing some questions from practice set 2.4 in this particular section. So here I have page number 43, question number 1. I have sub question 3. We'll be doing limited questions because this exercise is quite easy and I think you all should be able to do this exercise without any problems. So here we have y square is equals to 7y. We're going to bring everything to the left hand side. So I have y square minus 7y and I do not have a constant, so I'm just going to write a 0 here. So this is 0. Now I have to compare this to my standard equation, which is ay square plus by plus c is equals to 0. So my a value here is 1, b value here is minus 7, c value here is 0. This is a pretty simple equation. We've been doing this for the past 3 practice sets, and I won't be doing any more questions which are similar to this. You all should be able to do such kind of questions. We'll be moving on to the next question. We have question number 2. I'll be doing sub question 3, and here I have 3m square plus 2m minus 7 is equals to 0. So again, we'll be comparing this to our standard equation. Here I have am square plus bm plus c is equals to 0. So my a value here is 3, b is 2, and c is equals to minus 7. Simply putting the formula, I get minus b plus minus under root b square minus 4ac divided by 2a. This gives me m is equals to minus 2 plus minus under root 2 square minus 4 into 3 into minus 7 complete divided by 2 into 3. Now that implies m is equals to minus 2 plus minus under root 4. Now here I have minus 4 into minus 7, which becomes plus, and 4 into 7 is 28. So I have plus 28 into 3, and 28 into 3 is 84. So here I have 4 plus 84. This is divided by 6. So m is equals to minus 2 plus minus under root 88. This is divided by 6 again. M is equals to, now the one way I can write 88 is 4 into 22. So what happens here is that I can take under root 4 outside the square root and I can write it as 2. So this becomes minus 2 plus minus 2 under root 22 divided by 6 can be written as 2 into 3. So that means I have 2 common in the numerator and I have 2 in the denominator. So I can simply cancel 2 out. So m is equals to 2 common. I have minus 1 plus minus under root 22 divided by 2 into 3. 2 and 2 cancels out. So I am left with m is equals to minus 1 plus minus under root 22 divided by 3. So this is my solution for this particular question. Now we'll be moving on to our next question. I'll be solving sub question 5 and I'll be doing just sub question 5 for this particular section. So here I have sub question 5. The question is y square plus 1 divided by 3y is equals to 2. So here now we have a fraction involved, so all we need to do is take the LCM or multiply the equation by 3. So let's say I multiply the equation by 3. This gives me 3y square plus y is equals to 6. Now bringing it to standard form, I get 3y square plus y minus 6 is equals to 0. So now I'll be comparing this to my standard form. I have ay square plus by plus c, this is equals to 0. So the value of a is equals to 3, the value of b is equals to 1, the value of c is equals to minus 1. So y is equals to minus b plus minus under root b square minus 4ac divided by 2a. So this is equals to minus 1 plus minus under root 1 square minus 4 into, pardon me, this value is minus 6. So this is 4 into 3 into minus 6 divided by 2 into 3. So y is equals to minus 1 plus minus under root 1 plus 4 into 3 is 12 and 12 into 6 is 72. So here I have 72 divided by 2 into 3 is 6. So this is 6. So y is equals to minus 1 plus minus under root 73 divided by 6. And this is my final answer. Now using these two examples, you can solve the rest of the examples by yourself. There will be no extra questions in this practice set 2.4. This practice set is much easier than the previous ones. We'll be moving to our next topic, and in that we'll be discussing nature of roots of a quadratic equation. Now we'll be moving on to the topic nature of roots of a quadratic equation. So before we start this, we'll be seeing how real numbers function when they are squared. So here we have nature of roots of a quadratic equation. So I'm going to take two numbers. One of them is going to be positive, the other one is going to be negative, and we're going to see what happens. So here I have simple number minus 2. So I'll be taking a negative number, or rather I'll be taking a positive number first. Here I have a positive number. Here I have a negative number. And here we'll be seeing the square of the number. Now bear in mind that the number is going to be the same. That means the value of the number is going to be the same, only the sign is going to be changed. So here I have minus or plus 2. Here I have minus 2. Plus 2 and minus 2 both. If I square both of the values, the answer comes as 4. Now similarly, you can try any different amount of numbers. I have plus 3, minus 3. I have plus 3, minus 3. This turns out to be 9. And then similarly, we can move up. I'll go to 10. This is minus 10. This is plus minus 10. Square is equals to 100. And we'll be taking one last value. Let's say we have 20 minus 20 plus minus 20 whole square is equals to 400. Now we'll be focusing on this particular column over here. So now we know that plus and minus 2, both of these squares is 4. That means under root 4 is equals to plus minus 2. Now the one thing that we have to observe in this column is that whenever we square a real number, none of the squared value, that means these values, none of them are negative. So if I under root any value, let's say I under root 100, so the value is going to be plus minus 10. Now, as we can see that the values on the right hand side on the square of the number column, all of them are positive. That means all the values that have been squared are real numbers. But what happens if I have a number, let's say -4, and this is square rooted instead? Now this value has no defined value as of yet, so we cannot say that -4 or under root of -4 is not a real number, is not a real number. Now we are going to see why this is relevant in our nature of the roots of a quadratic equation topic. So if we see our formula by using for solving a quadratic equation using the formula method, we have x is equals to minus b plus minus under root b square minus 4ac divided by 2a. So as we can see, I have an under root value over here. So if this under root value becomes negative, that means I cannot have a real number. I cannot, or my solution for x is not going to be a real number, as we have not defined the negative square root of a negative number. So in the next slide, we're going to see how this will be defined. So first of all, b square minus 4ac is called as the discriminant. Now remember, it is not under root b square minus 4ac, it is just b square minus 4ac. It is also called as delta. So we are going to see three cases. So the first case is when b square minus 4ac is greater than 0. Greater than 0 means that the value is positive, and square root of any positive number is a real number. So this implies if b square minus 4ac is greater than 0, that means the quadratic equation has two roots which are different in value. Now, two roots which are different in value, this means that one of them is going to be +1 and the other one is going to be -1. +1 and -1 are two different values. The number is same, but the sign changes the value they pertain to. So now, if b square minus 4ac is greater than 0, the quadratic equation has two roots which are different in value. If you check your textbooks, it will state as the quadratic equation has two distinct roots. Two distinct roots means it has both the roots are different in value. Now we'll be seeing the second case. In the second case, let's say b square minus 4ac is equals to 0. So as we know, root of 0 is 0. That means 0 is also defined as of yet. So that means the solution for x is equals to whatever roots we get is going to be a real number. Therefore, if b square minus 4ac is equals to 0, or you can also write this as delta is equals to 0, the quadratic equation has two equal roots. Now we're going to see this why. So let's say I have x is equals to minus b plus minus under root b square minus 4ac. This complete is divided by 2a. Now as we have defined that b square minus 4ac is going to be 0, that means this particular value is going to be 0. That means the value that I'm going to get is x is equals to minus b divided by 2a, and there are going to be two solutions. One is going to be this, and the second is also going to be this. Therefore, whenever b square minus 4ac is equals to 0, then the quadratic equation has two equal roots. Now we'll be seeing third case. If b square minus 4ac is less than 0, that means square root is negative and this is not defined. This implies that the roots are not real. The roots are not real, or you can simply say that the roots are not real. So in the next section, we'll be learning some, or we'll be trying out some problems related to nature of the roots of a quadratic equation. Make sure you revise this before you start seeing the next section that we're going to do. I'll be revising this once again. B square minus 4ac greater than 0. That means my quadratic equation has two roots which are different in values. If b square minus 4ac is equals to 0, that means my quadratic equation is going to have two equal roots. And if b square minus 4ac is less than 0, that means the roots are not real. And one thing that I missed pointing out, that whenever we are talking about b square minus 4ac, we always compare the quadratic equation to our standard form. And the standard form is ax square plus bx plus c is equals to 0. That is how we get the values for b, a and c. That will be all for this section. Thank you.